Hey, Science 20s, it's time to talk about explosions! Oh, yeah. So, explosions and the formula for that is found again on page 2 of your data booklet in the top right-hand corner. Now, I'm going to show you one of my all-time favorite videos of an explosion before we start. Here we go.
Hi there, this is All Seer. I just was experimenting with fireworks for Halloween, and I think I've perfected the mixture with sulfur, and I'm using some potassium magnesium. So I'm going to light this, and it should just sparkle a little bit. I've got this protective cloth down here. Actually, I think I'll turn the light out so it shows up better. Let's try this out here. Holy smokes.
Holy smokes. Explosions. Okay, so we can do some physics with explosions by using the explosion formula. And it looks like this. Because things that have exploded are all one piece, the mass of the system is put together. Now, spoiler alert, most things that are going to explode aren't moving beforehand. So the whole left of the expression for us is always going to be 0. And then after the explosion, we are only looking at explosions that explode with 2 chunks. So this is before the explosion, and this is after the explosion. Also, you can see we have arrows above our velocity for direction. So direction is also going to be very important for explosions. All right. So we've got a grenade from Call of Duty Modern Warfare 15 or whatever we're up to right now. And it explodes on a camper because we all hate them, blows them to smithereens. Okay. So one piece flies one way to the right. Okay, so let's just say to the right is positive and to the left is negative. Okay. So one piece flies right and another piece flies. Oh, that's a typo. Let's change that to left. My bad. Yeah, so we're going to have one piece fly left. But we know how fast one chunk is going, but not chunk 2. So this is an explosion. Now, let's save some time because momentum before, if you think about a grenade, right? A grenade's sitting there not moving before the explosion. So its momentum is going to be 0. Okay, so I'm just going to go 0 is equal to m1 v1 plus m2 v2. So all of that stuff on the left, all of this for explosions for us is going to be 0. So we can save some time just saying that's 0 because the velocity of an explosion before it explodes is nothing. Okay. Now let's do our toolbox. So the mass of the first chunk, the little chunk, 0.015 kilograms. And the speed of the chunk is 3 meters per second. The mass of the second chunk is a lot smaller. And we don't know its speed. Okay, so let's put in what we do know. 0 is equal to m 0.015 kilogram times v1, 3 meters per second, plus m2, 0.005 kilogram times v2. So that's what we're trying to solve, is the speed of the second chunk. Okay, let's do a little bit of math. We can multiply these two values out, right? Those two we can multiply out. 0.015 times 3 gives us 0.045. 0.045. So 0 is equal to 0.045. And that's kilogram meter per second plus 0.005 kilograms times V2. Okay. Now we have to isolate V2. And what we can do, this gets a little messy. I'm just going to get rid of this link here because we're going to watch that after. We need to get this value on the other side. That's positive, so I'm going to subtract 0.045 kilogram meter per second. And what I do to one side, I have to do to the other. Okay, so 0 subtract that is negative 0.045 kilograms. Basically, kilograms meter per second is equal to, so that's gone, 0.005 kilogram V2. So basically what I did was I just moved this value to the other side, and the sign is switched. So if it was positive there, now it's negative. Okay, now we're almost done. Divide both sides by 0.005 kilograms. Divide this side by 0.005 kilograms. And I put that into my calculator, 0.045 divided by 0.005. And I get V2 is equal to 9 meters per second. But it's negative. And what did we say negative was? Negative is to the left. So we had something that exploded. One chunk went to the right, and a much smaller chunk went to the left. And the much smaller chunk, if we look, is moving much faster. So that kind of makes sense. Okay, video break time. And just a quick review. Remember, the left side of explosions will always be equal to 0. Remember to say one direction is positive and the other is negative, so you can figure out which way it's moving after. Okay, another fun video.
Guys.
Oh my God, it's on the roof. Oh my goodness, I love it. I love it so much. Okay. All right, let's do another explosion. Okay. So in an attempt to explode a dangerous clown, you make a pipe bomb. This is very illegal and you shouldn't attempt it. But remember, guys, as you know, clowns don't have a soul and are not protected underneath the War Crimes Constitution. Okay. So we have a bomb and it blows up. One piece flies north and the other piece flies south. How fast is the south piece moving? Okay. All right, so our formula is, remember, momentum before is 0, m1 v1 plus m2 v2. Okay. All right, so the mass of, let's say, north, what do you think? Should north be positive? Sure. And south is negative. Okay, north is positive. Remember, we have two different directions. Okay. Mass of the north chunk is 0.4 kilograms. And the speed of the north chunk is 90 meters per second. The mass of the south piece, it doesn't tell us the mass, but the whole bomb weighs 4 kilograms. And if we subtract that from the north chunk, the chunk that's left over is the south chunk. Now, I know in an explosion you're going to lose stuff to shrapnel and things like that, but we're going to pretend 100% of the mass is conserved. Okay, and we don't know speed of the second system. All right, so 0 is equal to mass of the first system, 0.4 kilograms, times speed of the first system, 90 meters per second, plus mass of the second system, 3.5 kilograms. And again, if I explain that a bit too fast, the whole bomb weighs 4 kilograms. And if we know that one piece is 0.4, when we subtract the two, that gives us the remaining mass. And we don't know the speed of the second system. Okay, so we can times out 0.4 times 90. and we get 36 kilograms meters per second plus 3.6 kilograms V2. Okay, so we have to get rid of this 36. I'm going to subtract 36 kilograms meters per second from this side. It cancels. And I'm going to subtract 36 kilograms meters per second from that side. Okay, perfect. Give myself a little bit more room. I wind up with negative 36 kilograms meters per second is equal to 3.6 kilograms V2. So just like the last problem, I'm going to divide both sides by 3.6 kilograms. And pow! The kilograms cancel, and I go 36 divided by 3.6. I get a very nice and even 10 meters per second. But it's negative. And what direction is negative, did we say? Is south. So we can either communicate that as negative 10 meters per second. That's cool. That negative means it's moving south. Or I can go 10 meters per second south. And if we look, the second chunk is way heavier, so it shouldn't be moving as fast. All right, guys, that's explosions. Now you have all the formulas that you need to answer the problems in the worksheet that's due by the end of the week. Make sure you pop into the Google Meets if you need some help.